Welcome. Let's do one more example. And this is one where the lower limit is not a constant, so we're going to have to split the integral. All right, and we're going to be using the fundamental theorem of calculus, part 2. All right, so we want the derivative, and this shows that the integral and derivative are inverse operations. All right, so you're going to split it with a constant. Doesn't matter, you can call it a or you can call it 0. I'm just going to call it 0. All right, so the lower limit has to be the 5x, so it goes from 5x to 0. Whatever constant it is, it doesn't matter because when we take the derivative, it would have canceled out any constants anyway, right? Because the derivative of a constant is 0. So 0 is good enough. So we're splitting it with the 0, and then we have 4t squared minus t to the 4th dt. Oops. Ignore that. There we go. That has to match. Plus, right, so now if the upper is 0 on the first part, the lower is going to be 0 on the second part. And then the upper limit of integration is x cubed, and then 4t squared minus t to the 4th dt. All right, so we've split it. Now the problem is that on the first part, the lower limit is not a constant. And it wasn't going to be a constant, right? Because the lower limit has to be 5x. But remember, you can flip and negate. To put the constant as the lower limit of integration. All right? So now we're going to make that, oh, you know what? If I put parentheses, it's okay that I only have one ddx there. All right, so the derivative, and then we're going to make this the opposite. Now the 0 is on the bottom, 5x is on the top. 4t squared minus t to the 4th dt. And then I'm just going to put the ddx over here, so I don't have to use so many parentheses. And so we're taking the derivative of the second part, which would go from 0 to x cubed of 4t squared minus t to the 4th dt. All right, so now we don't want to have to integrate, evaluate, and take the derivative because we know differentiation, integration, or inverse processes, and we'll be left with the same thing, right? This part, only now we'll have x's in there instead of the t's. All right, so we can substitute, so long as we remember, after we substitute, we're going to have to multiply by the derivative of each of our limits of integration there. All right, because they would have, if we integrate and evaluated and taken the derivative, we would be taking the derivative with the 5x and the x cubed. All right, so this is going to be negative 4 times 5x squared. Actually, I'm going to make sure I put parentheses there. 4 times 5x squared minus 5x to the 4th power, all times the derivative of 5x. Oh, you know what? I have a negative issue. Right? That's all in parentheses. Negative's on the outside. And then plus, so now we're substituting the x cubed. 4 times x cubed squared minus x cubed to the fourth, and then times the derivative. Let's move everybody over just a tad. Piece by piece, there we go. Times the derivative of the x cubed. All right, so we've got, I'm going to leave that negative out there, right, because the whole thing's the opposite. Right, so 5x squared is going to be 25x squared times 4. That would be 100x to the fourth. Wait, excuse me. Not x to the fourth. X squared. Right, 5x all squared is 25x squared times 4 is 100x squared. Minus, and then 5x to the fourth power is 625x to the fourth. We're going to take the opposite of that, and we're going to multiply by the derivative of 5x, which is 5, plus, right, so we've got 4x cubed all squared. It's an odd place where I put the parentheses in. But anyway, the 4 is squared, right? Oh, no, excuse me. The 4 is not squared, right? The x cubed is squared as I look above. It was exactly where I should put that parenthesis. So the x cubed is squared. The 4 is not. That makes that 4 x to the 6. I'm just double check and make sure, yeah, I did not square the other 4. Good. Minus, need parentheses there, minus x cubed to the fourth power would be x to the 12th, times the derivative of x cubed, which is 3x squared. So I gave ourselves a challenge problem here. All right, so let's distribute the negative and the 5. That's going to make this negative 500x squared plus whatever 625 times 5 is. There we go. Got the calculator on. 625 times 5, 3125. And it was more than 3,000. So 3125 x to the fourth plus 12 x to the eighth minus 3x to the 14th. All right, we add exponents to multiply like bases raised to a power. And there are not a single like term here. So we are done. All right, so just a little reminder of the steps. If the lower limit's not a constant, I gave myself here like the hardest problem I could, had everything in it. If the lower limit's not a constant, split the integral. And then if, again, the lower limit's not a constant, you're going to flip and negate. All right, so here we split it, we flipped it and negated so that we could be able to use that property, right, that the constant was going to drop out and it was just going to leave that upper variable in place of the variable that was already there. And it looks pretty good. Yep, I think so. All right, so thanks for watching. Bye for now.